Have you ever wondered why Earth doesn't have rings? Gas giants, Jupiter, Saturn, Uranus, and Neptune, have them. But the rocky planets, Mercury, Venus, Earth, and Mars, don't. Two theories describe how ring systems potentially developed. The first one says that rings may have formed from leftovers that date from the time a certain planet was forming. Or, as the second one says, they could be the remains of a moon that was either destroyed in a collision or broken apart by the gravitational pull of its parent planet. Scientists still don't know why the gas giants have rings, but they think it could be because they formed in the outer solar system. Rocky planets formed in the inner area of our solar system, which is why they were more protected from potential impacts and collisions that might have formed rings around them. Or the reason is that the bigger planets have a larger volume, which allows a ring system to remain stable. Some scientists think our planet did have a ring system a long time ago. In its early stage, a Mars-sized object hit the Earth, and this probably resulted in a dense ring of debris. But its ring system pretty soon coalesced, and that's the way our moon was formed. More than 10 years ago, in 2011, astronomers found a huge water vapor cloud about 12 billion light-years away from our planet. This cloud is the oldest source of water that we know of. It dates back to when the universe was only 1.6 billion years old, and now it's 13.8 billion years old. This unusual cloud is also the biggest source of water that we know of. It holds 140 trillion times the amount of water that the Earth contains in all its oceans. Enormous. The cool thing is, this vapor cloud is kind of feeding a black hole. It may contain enough gases, such as carbon monoxide, to help its black hole grow even 6 times bigger than it is now. We all know that Earth has one moon, but there are 2 more asteroids, 3753 Carina and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one, 2002 AA29, follows a horseshoe orbit around our planet. Its specific path brings the asteroid closer to us every 95 years. You'd expect Neptune to be an extremely cold and dark place. After all, it's an ice giant 2.8 billion miles away from the Sun. There's not too much sunlight there, so noon on Neptune is similar to twilight on our planet. But this ice giant appears to be creating its own heat. To be precise, 2.6 times more heat than it gets from the Sun. This probably has to do with all the pressure near the planet's core. It builds and releases hydrogen, which keeps Neptune's center at a crazy temperature of 9,300 degrees Fahrenheit. But its atmosphere is still quite chilly. It ranges from about negative 240 degrees Fahrenheit to negative 330 degrees Fahrenheit. What shape do you think of when someone mentions storms? Probably long ovals of hurricanes and conical tornadoes. But that's something we see on Earth. At Saturn's North Pole, a storm has been raging for at least the past 40 years, and it has a hexagonal shape. Such a weird shape probably has something to do with Saturn's turbulent gas, or maybe even with zonal jets that extend many miles down into a region of extremely high pressure. Have you ever wondered why planets don't twinkle while stars do? The thing is, if you were out there in space, you wouldn't see them twinkling at all. The reason we see stars twinkling is because of Earth's atmosphere. The pin-sized light coming from a star hits the atmosphere. The atmosphere then refracts it, which sends the light skittering off in a zigzag. That's what we perceive as the twinkle. Planets appear much bigger to us than just pinpoints. And yes, their light zigs and zags after hitting the atmosphere too. But those motions cancel each other out, which is why we don't see twinkling, but only a steady glow. In some regions, you can expect big changes in temperature. For example, in Montana, where in a single day, temperatures went from negative 54 degrees Fahrenheit to 45 degrees Fahrenheit. Yeah, sounds like a lot, but it's still nothing compared to Mercury, where temperatures tend to vary over 1,000 degrees Fahrenheit in a single day. They start out at negative 280 degrees Fahrenheit at night, and eventually go up to 800 degrees Fahrenheit during the daytime. Picture a wardrobe you'd need to prepare for a single 24-hour visit to Mercury. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter, and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. When you think of volcanoes, you probably picture hot molten lava coming out of them. At least, that's how it works on Earth. But in space, volcanoes can spew methane, water, or even ammonia. Up there, a volcano can also spew specific materials that freeze as they erupt. Then they turn into frozen vapor and some sort of volcanic snow. It's a common thing on Jupiter's moons Europa and Io, also on Pluto and Saturn's moon Titan. They're called cryovolcanoes, and Io has extremely active ones. Over there, you'd see hundreds of vents with plumes of frozen vapor that tend to extend about 250 miles. And NASA vehicles have even captured some erupting in real time. Bam! Planets, moons, asteroids, comets, and stars, they can all collide, and galaxies too. Our galaxy, the Milky Way, is 2.5 million light-years away from Andromeda, our closest galactic neighbor. Astronomers believe the Milky Way is on a collision course that will destroy both galaxies in the distant future. Or at least, galaxies as we know them. The two galaxies are going faster and faster toward each other at a rapid clip, 250,000 miles per hour. It will be chaotic, and many planets and stars won't survive the collision. Eventually, these two massive entities will merge and turn into a completely new, unrecognizable galaxy. But here's a small comfort. Scientists assume this is not scheduled to happen for another 4 billion years. In case you want to fuse two pieces of metal together, you already know the only way to do that is to apply heat so these pieces can reach their melting points. In space, you don't need heat to do such a thing, or basically, any action at all. We call it cold welding, and such a phenomenon happens when you slide the metal pieces over each other. In that case, they wear away their protective oxide layers. On Earth, these layers stop them from fusing, but in space, this type of protection disappears. That's why the electrons from one piece of metal just flow into the other piece. And ta-da! They're one without any effort. Scientists used to believe the Earth was the only planet in our solar system with tectonic activity going on. Tectonically active means plates under the crust are moving. This process releases heat, which then deforms the Earth's surface and leads to its shrinking. But now, we know this happens on other planets too. Mercury is also shrinking, and scientists found it out in 2016 when the Messenger spacecraft orbited the planet and sent back some important data. It revealed that there were cliff-like landforms known as fault scarps on Mercury's surface. Since these landforms are relatively small, they probably didn't form that long ago. That means Mercury is still contracting, even 4.5 billion years after our solar system was formed. Jupiter's Great Red Spot is shrinking as well. It's a huge storm that rages on the planet's surface. It's reddish, a bit oval in shape, and more than 10,000 miles wide. Yep, that's big enough to swallow the Earth. And now, it's been slowly but surely shrinking for a couple of centuries. The Great Red Spot is just one of many high-pressure storms that occur across Jupiter due to all those gases present there, which is something that classifies Jupiter as a gas giant. But just because it's shrinking doesn't mean the Great Red Spot is going to blow itself out anytime soon. It's even growing taller. Imagine all the planets from the solar system had a meeting and decided that Earth should move to another galaxy. Then what? Well, my friends, if Earth got kicked out of the solar system, let's just say we'd be in for a bumpy ride. As you may know, each planet occupies its own orbit in relation to the Sun, guaranteeing the perfect functioning of our solar system. But it wasn't always like this, though. Billions of years ago, planets and asteroids kept constantly bumping into each other. It took some time before each planet found its own personal orbit, and our system took the formation it has today. Now, as you may know, the most important organizing factor of the solar system is gravity. Gravity attracts every piece of matter to every other piece of matter in the universe, and the bigger the mass, the bigger the gravity. The Sun makes up 99.75% of all the mass in the solar system. It's precisely the Sun's gravitational pull that has kept Earth on a steady and reliable path. But it wouldn't take a surreal interplanetary meeting for Earth to go rogue. This is an actual possibility, an unlikely, but real one. For instance, if any rogue planet or star were to travel close to the solar system, its gravitational force could mess up our planetary organization. And did you know that this has actually happened before? Some 70,000 years ago, a red dwarf passed through the Oort cloud and messed things up. The Oort cloud is an outer circle of space debris located on the edge of our solar system. It lies far beyond Pluto and the Kuiper belt and surrounds the Sun in a giant spherical shell. Apart from the 8 planets and the Kuiper belt, there is another asteroid belt between Mars and Jupiter. Now, scientists expect another red dwarf to pass by our solar system. It's an orange star from the constellation of Serpens Cauda. Astronomers expect it to pass near the Sun in about 1.29 million years, at a distance of about 99 billion miles. This star has about 60% of the mass of the Sun, which would be enough to cause a great disturbance in our system. Once the star entered our system, we'd be able to see it in the night sky without any equipment. It would be like watching a small orangish dot appearing in the sky. Over the months, it would grow bigger and bigger until we'd see it during the daytime. At a certain point, it would become so big and bright that we wouldn't be able to look at it directly. Just like people say we shouldn't do with the Sun, but we look at it directly anyways, right? At this moment, the night sky would fill with an eerie red glow, and after a few months, the orange star would start shrinking again, turning smaller than the Sun. But then, wait, the Sun is turning smaller too. Well, yes. The passing of Gliese 170 took Earth out of its orbit, and its gravitational force pulled us out of our natural alignment. Now the Earth will roam through the solar system until it reaches outer space. So, what would happen with our planet if this were to really happen? First, the Earth would leave what is known as the Goldilocks zone, also known as the habitable zone. It's a rather narrow part of the solar system where human life can thrive. What's its success secret? Water in a liquid state. Astronomers have discovered that Mercury also has water, but only in its northern and southern poles, where light never reaches. Pluto, the dwarf planet at the rear end of the solar system, is 30% water, but much of it is hiding under a thick layer of ice. If the Earth ever did leave its privileged place orbiting the Sun, it would travel around the galaxy at its orbital speed of 67,000 miles per hour. That's 1,000 times faster than a cheetah can run. Pretty fast, huh? So, in about more or less a month, humanity would see the red giant Mars on the horizon. By then, we would be getting around 44% of the sunlight we once had. If someone wanted to begin a new civilization, this would be the perfect moment. With reduced sunlight, it would be more difficult for plants to continue doing photosynthesis, so most of the flora on our planet would begin to perish. A few days after leaving Mars's orbit, our planetary spaceship would face its first challenge, traveling through the asteroid belt. It's a collection of small, rocky, metallic bodies. They're basically leftovers from the Big Bang that created our solar system 4.6 billion years ago. So, in a way, it's almost like we were traveling in time. right? Luckily for us, the distance between one asteroid and the next is about 600,000 miles. So, after passing one asteroid, it might take us a while before running into the next. If we make it through this journey intact, then we'll see the first gas giant in our galaxy, Jupiter. Up until this moment, our loyal moon has been following us as we travel inside the solar system. But, Jupiter's huge mass might steal our moon away from us. After all, Jupiter's gravity is twice as strong as Earth's. If our moon did join Jupiter's orbit, it would be no less than its 80th moon. A bit too many moons, if you ask me. At this point in our travels, the Earth's atmospheric temperature would have fallen drastically to around negative 229 degrees Fahrenheit. So life on Earth would only be possible in very specific places. Most of our planet's water would be frozen at this point, but only on the surface. Thanks to the Earth's core activity, it would heat our oceans from below, allowing heat to escape and maintain some water in the liquid state. In fact, the Earth's core would remain active for billions of years after it has left orbit. In this scenario, microbes living near hydrothermal vents would thrive. But perhaps some life would also be possible near the heat provided by thermal vents above the surface, in places like Yellowstone Park. A great option for humanity would be to build cities deep underground. This would be our best bet if we wanted to keep human life on planet Earth. 10 years after our departure, we would be deep into the interstellar voyage. We'd be over 2.8 billion miles from the Sun. Our solar system would be nothing but a distant memory. If you were still living on Earth at that point, then you'd probably be coexisting with great technological advancements. Humans could build entire underground cities using geothermal energy. Maybe we'd even discover how to turn ice into power and create a sustainable and abundant system for fuel. Ice would also be our main source of water, and by then, the transformation process wouldn't be as expensive. Underground crops would thrive, but some plants would be better than others. Moss, fungi, and algae would be some great alternatives, as they are much easier to farm and grow in large numbers. This would mean that most of our diet would be plant-based, as it might be hard to keep grazing animals under the ground. Humanity could go on living thousands of years this way. If Earth happened to pass by some star with a habitable planet, we might even attempt to make a home on another planet. Spaceflight would become easier without the atmosphere in the way. So, the idea of venturing into other planets would no longer seem too surreal in this scenario. The only thing that we would rather not happen to us is Earth running into a black hole. If that happened, let's just say we'd all be turned into spaghetti. Not literally, but we would go through a process that is called spaghettification. In this case, planet Earth, and everyone still living on it, would be vertically stretched up to the point of, vanishing. But that's the subject of another video. Fortunately, even if all this could be true, we wouldn't be caught by surprise. Thanks to scientific and technological advancements, we would be able to predict if a star were to pass too close to our home planet. And even if we couldn't stop a star, we would most certainly manage to do everything to prepare. So, who knows? Maybe the future generations will be watching this video, surprised at how precisely we figured the future out. In July, when we're about 94 million miles from the Sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, If the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. But it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the Sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the Moon was way closer to our planet than it is now. Luckily, we aren't going to lose the Moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the Moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth, and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules, and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead. And the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, Getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the moon has on Earth, our planet is gradually rotating slower and slower, and I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together.